In this lesson, we are learning about interpreting exponential functions. This graph shows the number of mold spores on an orange as a function of time. Is this growth or decay? We are going to ask ourselves, as our x values increase, go to the right, do our y values increase? In this case, they are going up. So therefore, this would be a growth function. Next, we want to ask ourselves, what is the initial amount? The initial amount is the same as our y-intercept. Our y-intercept is between 0 and 5,000, so we could say it is 2,500. Next, we're going to look at the domain and range. The domain is our x values. Domain, while it's normally negative infinity to positive, we are talking about a real-world situation where time cannot go into the negatives. We cannot go backwards in time. So our domain is going to be from 0 to infinity. Our range is going to start at 2,500 because that's our initial time, and it's also going to go to infinity. About how many mold spores would be on the orange after 3 hours? Time in hours is 3. We come right up here. What would that be? We could say about 23,000. This graph shows the change in the value of a car over several years. Is the value of the car increasing or decreasing? As time goes on, our x increases, our y values are going down. So this is a decreasing. Is the graph linear, quadratic, or exponential? How can you tell? We have a very sharp drop. So it's not linear because it's not a straight line. It's not a quadratic because we don't have a vertex where it starts to come back up. So this is going to be an exponential function. And the last question, from year 0 to 3, how much did the value change? The car started here. We'll call it $12,000. At year 3, it was at $6,000. So there was a $6,000 decrease. How does this number compare to the initial value? Well, 6,000 is actually half of 12,000. Another graph for us to interpret is this worker's annual salary increasing or decreasing? As we move to the right or increase on our x values, our salary is going up. So this is an increase. How much is this office worker's initial salary? Remember that initial is the y-intercept. Initially, they are earning $5,000. And to plug this into an exponential equation, the important thing here is that you recognize 5,000 is going to go in where your A goes in. This graph shows the number of coffee stores after 1992. Is this graph linear, quadratic, or exponential? Again, it's not a straight line. We don't see a vertex where it goes back up on the graph. So that leads us to believe this is an exponential function. How many stores were open in 1992? So this is saying after 1992. So 1 year after 1992, 2 years, 3 years, 4 years. So 0 years at 1992, how many are open? We're looking for our initial value, which would be 400. C says, which of the following equations might fit this data? We know that 400 has to be our A value. So this one does not work. A is 400, A is 400. The difference in these two is whether or not we're growing or decaying. This first one, B is bigger than 1, so this is a growth. The second one, B is between 0 and 1. This is decay. Again, we are, as number of years goes up, so does the number of stores. So this is a growth function.